Welcome to the very first TMC webinar. It's a pleasure to have you with us. And before we start with our actual topic, a bit of an advertisement before. So TMC is planning to do a series of webinars. Today is the first one. Really happy and really looking forward to all the other webinars coming up during this year. So the next ones you can see here in the current slides. So today we're talking about machine clearance measurements and checks and how we are going to make them very easy. The next upcoming one in July is some tips and tricks and expert insights into our very own automatic guidance system, TMAGC. In August, we are going to talk a bit about how digitalization and automatization are bringing process safety into railways and railway maintenance in particular. And we have a very interesting load of a lot of other webinars coming up this year. The plan is to have one once per month. But now let's focus on today's topic. So we are talking about machine clearance measurement and how we, with our solution team MCM, are going to make that very easy for you. Generally speaking, TMC is offering a broad variety of products and solutions, which we are structuring in mainly three major departments: machine fleet and infrastructure, and TMMCM. Our today's focus is in the area of fleet at home, where we have a lot of different solutions for the fleet operation. All right, so who is this webinar for today? So we are focusing on people that are producing, validating, homologating, or at the end of the day also buying and owning machines, rail-bound vehicles, rail cars, wagons, and so on. So this is the target group of today's webinar. And anybody else joining who does not see himself in this group, one of these groups, no issue at all. Think about it and let's talk also later on then after the webinar if you have some ideas or are interested into the solution anyway. So what is clearance measurement, machine clearance measurement? How is it done until now, conventionally, traditionally, and how does our solution look like and compare to? So clearance measurement. What you can see on the right side is a cross-section of a machine. You will see a lot of these pictures and similar ones during this webinar because this is coming from our very own solution. But what you can see here is the machine and the outer bounds of the machine. And what you can see here in black, this is a clearance profile. And what you can see here, it's very, very tight around the machine because a machine is built nowadays to fully utilize the space it has within this black bounding box. And this black bounding box is the clearance profile describing the absolute maximum of space and the maximum of the region a machine can be within, and nothing, absolutely nothing, is allowed to be outside this clearance profile. So this is very important. It ensures safety and is part of the validation and the homologation of machines. And the thing is, this can vary a lot between different countries and between different infrastructures and environments. And this needs to be checked against wherever a particular machine will be delivered to. How is this done traditionally? So what you can see on the right side here is a machine going through a let's call it portal or gate. And the red one, the inner part of this gate, this is a clearance profile. And this is more or less the traditional way how a verification of clearance profiles is done nowadays, still very manually, very physical, because this machine goes through. And if there is anything outside this particular clearance profile that is mounted, in that case in this portal, the part is popping up or ringing a bell or whatsoever, signaling that there was something touching this particular clearance profile. And this is very manual. And this is the process for one clearance profile. And very often, the environment where a particular machine is going to being operated has to support and has to be verified against a set of clearance profiles. It's not always only one, but it's a set of clearance profiles. So this means that you need to have, for every clearance profile that is of relevance for this particular machine, a physical copy of this profile that has to be produced. And the whole process of mounting it and going with the machine through it and checking against it has to be done for every single of these clearance profiles. So a very cumbersome, absolutely not automated, a very manual and mechanical way of verifying this. So what I can see now here on the right side, this is a 3D digital copy of a machine, which is the product or one of the deliverables we are able to provide to you when using and working with MCM. So we do the very same, but fully digital. We do not need any mechanical portals anymore. We need a scanner, we need some processing and have a digital version and can do all the checks, everything in a fully digital, fully automated, fully repeatable and fully documented way. And how does this look like? Before we go into details, is on this slide here. So first of all, on the left side, you can see the scanner that we are utilizing. And on the right side, you can see the product, the result, the processed digital copy of a machine where you can then fully interact and produce all the relevant checks and reports, which I'm describing now in detail. So a completely different world, fully digital, the next step, going away from this manual and physical way of doing clearance checks. So now some details. The workflow overall consists of 3 major steps. First of all, you need to capture the machine. Then you're producing the point cloud model. And finally, with the resulting model, you can do all the checks and analysis and report generation then you would like to do. So going into detail of the first step, the machine capturing. So first of all, we need the machine. Of course, our model, what we are capturing. So what we need to have as a prerequisite for the capturing process is putting the machine somewhere where some space around the machine. We have some requirements on the minimum and maximum distance of the scanner. We are using its scanner of the Regal, and to be able to capture the machine, we need to position the machine somewhere where there is a space around it. We are talking about something between 2 minimum of meters, ideally 5 meters of distance to the machine, around the machine. The reason for that you can see in the next step, because we are positioning the scanner you can see the animation at the bottom here, step by step around the machine, putting the Regal scanner on a tripod with roughly 5 meters of distance between each scan around the machine, and scanning here on the medium height in 5 meter different distance between the scans once around the machine. Then we do the same at the very bottom, putting the scanner one round around the machine without the tripod to be able to capture all the details also on the bottom area of the machine. And finally, some additional scans with the extended tripod to also catch all the details on the roof of the machine. So positioning the scanner here looks like this in reality. So the middle or average machine height on the tripod, the scans on the ground level to capture all the details at the bottom, and some additional ones from the top. Additionally, we need to mount so-called reflective markers. You can see them here at the bottom, those pictures. These reflective markers are mounted on both ends of the machine, so we ensure that we detect at least one per scan, which is of relevance for the automatization of the merging and positioning of the machine then in the next step. All right, so the point cloud creation, the second step. So we did the capturing of the machine, and that's it. We do not need the machine anymore. We do not need to access the machine. We do not need to have an additional round. So we are done on site. We take the data from the scanner into the back office and then process the data here in a multi-step approach, semi-automatized, into the final model. So first of all, we are registering the single scans. This is the registration is how we call it for loading all the single point clouds into the system and merging them together. So the merging and the data cleaning and the transformation is what needs to be done here to achieve this final model for the checks at the end of the day. Because we are merging the single point clouds into one big one and colorizing it, cleaning any noises, artifacts whatsoever that is not of relevance for the checks, and also bring it into a proper coordinate system, which is done ideally automatically when we have a proper detection of all the reflectors that are mounted on both ends of the machine. All right. And then we're good to go for the final step, which is the analysis. So what you can see here is one step in the overall process in our software, the TMMCM machine clearance software. And you can see here on the left the first step of the preparation for the generation of the report. So you always have the possibility to see in a 3D viewer, so this is the video running on the right side, the model and how it looks like when you take out a slice of the data and the selected clearance profiles. And you can, on the left side here in the UI, for the generation of the reports, prepare the report in a way by adding certain meta information, by defining all the processing parameters. So for the length of the sections, for example, coming to that later on, and also selecting the relevant clearance profiles. You can see here the static profiles. We have a huge clearance profile database already available, talking about over 120 different clearance profiles from different regulations already out of the box available and can be easily extended here as well. And you can, not sure if you see it also, there's also a possibility to switch from static profiles to dynamic profiles and load any dynamic profiles that were provided to you by the manufacturer of the machine. Then you have the possibility to check here if the 0 point is fine, so it's automatically defined from the point cloud in reference to the reflectors and in reference to the rail, but you can adapt it if you want or if you need it. And then you can also additionally define the start and the end for the report. So generally speaking, or per default, the start and the end of the vehicle is selected. But you can, if you need to do for a particular region, for example, an additional report focusing on certain parts of the machine, can additionally define manually the start and the end point for the report. Yeah, and then the report is generated, and this is a huge report, very detailed, where you have, first of all, the overview giving you an immediate indication of is everything fine. So like on the very left, so like everything is green, everything has a check mark, so everything is fine. But then you can go into the details on the right side here, for example. You can see this red box. And this red box is a so-called region. And on the next page here, you can see the detail evaluation of a particular region. So the length of these regions you can define at the beginning of the report generation in the parameters. And then the evaluation is done for each and every single of these regions additionally. So you can immediately see if there are any issues in particular regions. Where I have an example for you brought for this presentation. So what you can see here is on the top left, you can see that there is something, in this particular case, it's a light bulb that is very close. It's not over the clearance profile in this example, but it's very close to, and the system immediately informs you. So with this color schemas, that there are some eventually problematic parts, which could be, for example, fine for the static evaluation, but could be eventually an issue for the dynamic evaluation. And this particular example, this light bulb here, can then be evaluated also in the 3D model, of course. So you can open up that section. You can see here the hull of the static clearance against the 3D model. You can see here the colored dot is the light bulb. And you can also see in the 3D view with the cross section here, once again, zooming in on this detail and see what this object is, what the issue is, and can go in all the details of this report. So you have this report generated automatically. So you have the full documentation, you have the check, but you also have the full documentation against the relevant clearance profiles of particular regulation for a given customer. So you have full control of your checks, and you also have full documentation of these checks. All right. So the webinar is planned to be 15 to 20 minutes, I think. So we try to keep it short, not too long. So that was a rough and high-level overview of how the system works. As a conclusion, I try to summarize once more. So we working on these systems since some time now. Productized and introduced it last year. We already did 60 machines. And what does it mean when I say we did 60 machines? Because TMMCM you can buy as a full system from us, but we're also operating it as a service. So if you have the need For getting a full clearance check, including full documentation from us, please also get in touch here about this topic. And we already, since last year, did 60 machines. Different machines for different countries also. So this is an excerpt of machines delivered to a lot of different countries already, which means also, of course, that a lot of different clearance profiles are of relevance. We are constantly also building up our clearance profile database we are supporting out of the box. As I said at the beginning, it can be extended, of course, but we already have 120 profiles in the system, static profiles, which can be just selected out of the box and applied to the report. Yeah, so this is a modern state-of-the-art solution for the problem of doing machine clearance checks and also getting a full documentation of the machine as it is built, and a full documentation of the check in form of a PDF report with all the details for you at hand. And this is a major step up to traditional ways of doing this. And if this is of relevance for you and if you're interested into, feel free to get in touch with me. Here are my contacts. So just contact me, and I'm looking forward to get in further discussion if this solution is of relevance for you and your rail-bound vehicles. No matter if you're a manufacturer, somebody is in the process of homologation of these machines, or you are planning or in the process of buying or operating a machine, I'm open up here for any further discussion. Just get in contact with me. And if there are any questions, I think we take a few more minutes for a Q&A directly now. If there are no questions, as I said, just feel free to get in touch with me later on. Thank you very much. And I'm here for a few more minutes. For any questions, feel free to post it in the Teams webinar. I hope this works, that you can just post your questions and I try to answer them in the Q&A section of the Teams webinar. If not, thanks for your attention. Thank you very much for taking time to joining, and looking forward for any further discussions with you in a one-on-one session then. Thank you very much. So yeah, one question, distance for the scanners. I briefly mentioned it at the beginning. So we have an absolute minimum distance between the scanners and the machine of 2 meters. Ideal distance is 5 meters around the machine. So a bit of a space around the machine is good and important. You mentioned workshop, inside workshop. So yeah, 5 meters. If you can free up the space for the scan, it's very fast. The scan itself doesn't take very long, just putting the scanner around the machine. As you saw it in this sweet animation before, some scans and then you're done. So if you can, for this period of time, free up the space to have these 5 meters around the machine would be ideal. All right. So I think we conclude for today. Thank you very much. I will close the webinar. I hope you enjoyed it and looking forward to your feedback and your contact. See you in July with the next webinar. Thank you very much and have a nice day. Goodbye.